Introduction to Sift. What is Sift? Scale Invariant Feature Transform is a feature detection algorithm in computer vision to detect and describe local features in images. Applications include object recognition, robotic mapping, and navigation, image stitching, 3D modeling, gesture recognition, video tracking, individual identification of wildlife, and match moving. So Sift has scale space extrema detection. So when detecting larger corners, we need larger windows for this scale space. So this type of filtering attempts to identify those locations and scales that are identifiable from different views of the same object. So it is a detection na the same images, the same object but a different angle, but they have same features, but when it comes to angle, pag i-detect na siya sa angle, lahi ang mga feature detection nga magwas. So Laplacian of Gaussian acts as a blob detector, which detects blob in various size due to change in. In short, acts as a scaling parameter. So Gaussian kernel with low sigma gives high value for a small corner. A Gaussian kernel with high sigma fits well for a larger corner. A local maxima across the scale space gives us a list of x, y, and a zero values, which means there is a potential k point at x and y at scale. This difference of Gaussian obtains as the difference of Gaussian blurring of an image with 2 sigma. This process is done for different octaves of the image in Gaussian pyramid. So this is the two window na siya scale from first octave and the next octave. So there is a two filtering, which is the Gaussian and the difference of Gaussian. Once the difference of Gaussians are found, images are searched for local extrema over a scale set space. 1 pixel in an image is compared with 8 neighbors as well as 9 pixels. So as you can see here, na duha ka windows, the small corner and the larger corner. So sa duha ka windows, naggamit og duha ka bulk filtering, which is si Gaussian o the difference of Gaussian. So once ang difference of Gaussian are found, images are searched for local extrema over a scale and space. 1 pixel in an image is compared with its 8 neighbors as well as 9 pixels in next scale and 9 pixels in previous scale. If the local extrema is a potential k point, basically means that the k point is best represented in the scale. Regarding the different parameters, the paper gives some empirical data which summarizes number of octaves, number of scales, initial sigma, etc. as optimal values. So, muna siya ang windows so as you can see na ang 9 pixels sa first, and then sa previous is also 9 pixel, and then sa yung neighbors it shows na 8 bulk neighbors. K-point localization. Once potential K-points localization are found, they have to be refined to get more accurate results. They use Taylor series expansion scale space to get more accurate location of extrema. and if the intensity of this extrema is less than the threshold value 0.03 as per paper, it is rejected. This threshold is called contrast threshold in OpenCV. Difference of motion has high response for edges, so edges also need to be removed. 2x2 Hessian matrix to compute the principal curvature. If the ratio is greater than the threshold called edge threshold, that the K-point is discarded. It is given as 10 in per paper. It eliminates any low contrast K-points and edge K-points, and what remains is strong interests. Orientation assignment. Orientation is assigned to each K-point to achieve invariance to image rotation. A neighborhood is taken around the K-point location depending on the scale. The gradient magnitude interaction is calculated in that region. An orientation histogram with 36 beams covering 360 degrees is created. Weight by gradient magnitude and Gaussian weight circular window would equal to 1.5 times the scale of K-point. The highest peak in the histogram is taken in any peak above 80% of it's also considered to calculate the orientation. It creates K-points with the same location and scale, but different direction. It contributes to stability of matching. K-point descriptor. K-point descriptor is created as 16 by 16 neighborhood around the K-point is taken. It is divided into 16 subblocks of 4 by 4 size. For each subblock, 8 bin orientation histogram is created, so a total of 128 bin values are available. It is represented as a vector to form K-point descriptor. In addition to the several measures are taken to achieve robustness against illumination changes, rotation, etc. K-point matching. K-points between two images are matched by identifying their nearest neighbors, but in some cases, the second closest match may be very near to the first. It may happen due to noise or some other reason. In this case, ratio of the closest distance to second closest distance is taken. If it's greater than 0.8, they are rejected. It eliminates around 90% of false matches, while discarding only 5% correct matches as per paper. Sift and OpenCV. So I have a sample code here since we don't have a Sift in OpenCV. The package is already not available. I have a example of an image nag-detect niya. So as you can see here, i-detect niya ang mga features sa duha ka images. And next, iya rin i-detect ang mga match sa duha ka images. And then the result, i-show niya ang mga ga-match sa images. Another example is this one. Na duha ka images na they have the both parehas sa silang object, pero they have different they have different angles. Since duha ka images detect ang ilang features and then they match. Introduction to surf. Speeded up robust features is a feature detector, a sort of derivative of Sift. SURF is based on sums of 2D HAAR wavelet responses and makes an efficient use of integral images. In Sift method, we use difference of Gaussian to build image pyramid. In SURF, we simplify use an integer approximation to the determinant of Hessian glove detector. In Sift, we approximated the Laplacian of Gaussian with difference of Gaussian for finding scale space. SURF goes a little further and approximates log with box filter. Below image shows a demonstration of such an approximation. One big advantage of this approximation is that convolution with box filter can be easily calculated with the help of integral image, and it can be done in parallel for different scales. Also, the SURF rely on determinant of Hessian matrix for both scale and location. So this two-box filter shows the time of the summation of this two-box filter shows the approximation of Hessian. The convolution of the Gaussian second order derivative with the image I in the point x, and similarly for Lxy and Lyy. This approximates second order Gaussian derivatives and can be evaluated at very low computational cost using integral images. And this part of the reason why SURF is fast. Now we represent the determinant of the Hessian. So the determinant H approx equals to dxx dyy minus weighted the square root of w dxy. For orientation assignment, SURF uses wavelet responses in horizontal and vertical direction. For neighborhood of size 6s, adequate Gaussian weights are also applied to it. Then they are plotted in a space as given in below image. The dominant orientation is estimated by calculating the sum of all response within sliding orientation window of angle 60 degrees. Interesting thing is that wavelet response can be found out using integral images very easily at any scale. For many applications, rotation invariance is not required, so no need of finding the orientation, which speed up the process. SURF provides such a functionality called upright SURF or USURF. It improves speed and is robust up to 15 circ. OpenCV supports both depending upon the flag upright. For feature description, SURF uses wavelet responses in horizontal and vertical direction. Again, use of integral images makes things easier. A neighborhood of size 20 seconds by 20 seconds is taken around the key point, whereas the size is divided into 4 subregions for each subregion. Horizontal and vertical wavelet responses are taken and a vector is formed. This, when represented as a vector, gives SURF feature descriptor with total 64 dimensions. Lower the dimensions, higher the speed of computation and matching, but provided better distinctives of features. For distinctiveness, SURF features descriptor has extended 128 dimension version. Another important improvement is the use of sign of Laplacian trace of Hessian matrix for underlying interest points. It adds no computation cost since it is already computed during detection. The sign of location distinguish bright blobs on the dark backgrounds. From the reverse situation in matching stage, we only compare features that have the same type of contrast. As shown in the image below, this minimal performance allows for faster matching without reducing the descriptor's performance. In short, Surf adds a lot of features to improve the speed in every step. Analysis shows it is 3 times faster than Sift, while performance is comparable to Sift. Surf is good at handling images with blurring and rotation, but not good at handling viewpoint changing and illumination change. So first, there is two circles that can do much, second can do much, and the third no matching. So since kasi Surf wala na siya sa package sa OpenCV, there is an image example na ka-show siya sa example of an OpenCV. So, as you can see sa image, naka-grayscale siya para dali ra ma-detect ang key points. So, as you can see, so first, detect niya ang mga key points na similar sa object na nasa real-time o nasa object. And then, there is a second na images. Sa image, pag-rotate sa object, i-detect mas daghan siya na-detect na similar key points dito sa image o sa actual na object.